2.1 linear functions. Linear function can be represented with the following equation. F of x equals mx plus b, where m is the slope and b the y-intercept. So the slope can be expressed as rise over run, or y2 minus y1 over x2 minus x1. So if we have 2 points on the line, x1, y1, and x2, y2, the slope is the distance, the vertical distance between the points over the horizontal distance. So this is the rise, and this is the run. Okay, example. For calculating slope, if we have points 0, 0 and 2, 4, find the slope. Find the slope of the line PQ. So in this case, we write the formula and substitute. So 4 minus 0 over 2 minus 0 is 4 over 2, or the slope is 2. Another example. So this is A, B, the point P is 2, 3, and Q, 2.1, negative 1. So the slope is, we can label the points here, x1, y1, x2, y2. So negative 1 minus 3 over 2.1 minus 2. So that's negative 4 over 0.1, which is negative 40. C. Point P with coordinates 4, 3, and Q with coordinates 4, negative 2. The slope is negative 2 minus 3 over 4 minus 4, negative 5 over 0. It's undefined. We abbreviate that with UF, undefined. We cannot calculate it. So we see that the slope can be written as delta y over delta x, and it's often the rate of change in word problems applications. So the equation of the line can have several forms. We have point slope form, and that looks like y minus y1 equals mx minus x1, where of course m is the slope and x1, y1 is the given point. And slope intercept form, y equals mx plus b. So example, write equation of a line that goes through the following 2 points, negative 1, 3, and 2, 1. So 2 points are given, we can always find the slope, and that's what we're going to do first. So the formula, label your points. So 1 minus 3 over 2 minus negative 1, negative 2 over 3. is our slope. So then we pick one of the points, doesn't matter which one. Let's do -1, 3, and you write the point slope form. So that would be y minus 3. We want to label the point x1, y1. Y minus 3 equals -2/3 x plus 1. And simplify it. So we're going to distribute. We're going to add 3. And we have finally y equals -2/3 x plus 3 minus 2/3. Y equals -2/3 x. So that becomes 7/3 if you add the fractions. So graphing linear function. We're going to identify the slope and the y-intercept first and then graph. Example, f of x equals 3x minus 1. The slope is 3. The y-intercept is -1. So we start with the y-intercept. We plot it. That's -1. The slope being 3 can be written as 3/1. So that means up 3/1. And here's our line. Example, graph f of x equals 3. This is a special line. You can try to write it as 0 times x plus 3 if you wish, and identify the slope is 0, the y-intercept is 3. So if the y-intercept is 3 and x can be anything, the graph is a horizontal line. Last example, f of x equals 3 minus 2x over 4. It doesn't look like the equation is in a slope-intercept form, but we can rewrite it 3/4 minus 2/4x if you divide by 4 everything, and then simplify and switch. So we have x first. And now we can identify the slope, and m is -1/2, and the y-intercept b is 3/4, which is 0.75. Can help us graph. So the y-intercept here is 1. If this is 1 here, the 0.75 is somewhere here. The slope is -1/2, so it means down 1/2, and the line is falling down. So this is 0.75, and the slope is negative. And this concludes the lecture 2.1.